in this question, where we have the limit as x approaches 0 of root 2 plus x minus root 2 all over x, we are asked to evaluate this limit. If we look at the numerator of this function, we see that it is actually part of the difference of two squares. Now, to be able to move forward, we need to remind ourselves of the difference of two squares. If we have a squared minus b squared, we know from the difference of two squares identity that it is a minus b into a plus b. Now, looking at that numerator there, we can fabricate a similar difference of squares identity wherein we bring in the radical sign. This time around, instead of a squared, we have a. Instead of b squared, we have b. All right, bringing in the radical, we'll have the right hand side to be, in the place of a here, we'll have it as root a. In the place of b, we'll have it as root b. The same thing over here, root a plus root b. Here we now have the radical signs. If we look at the numerator, it is the minus. So we make out the minus here to be the subject of this expression. That means we're going to divide both sides by root a plus root b. So now we have a minus b all over root a plus root b will give us root a minus root b. So this is the expression that will enable us transform that limit expression over there. The root a minus root b will take the part of root 2 plus x minus root 2. So if we match it up, let us match it up and see. We'll put root 2 plus x minus root 2 on the right hand side. On the left hand side, let's match things for match. A here, remember, it stands for root 2 plus x, and b here stands for root 2. So if there's no square root sign, it means we have squared this. If we square this, we're going to have 2 plus x minus, if we square this, we're going to have 2 divided by, remember again, a is 2 plus x and b is 2. So we're going to have this identically equal to this. So in the place of that numerator now, we're going to write this expression. So our limit now becomes limit as x approaches 0 of 2 plus x minus 2. We just first of all simplify this numerator. 2 minus 2 is 0. So we have x up there divided by root 2 plus x plus root 2. Okay, that's it for the numerator. And then now divided by x. So the limit that we have up there has been transformed to this limit after using the identity of difference of squares. This expression can be simplified further. We can see x divided by x, so they will just cancel off. And so our limit process becomes limit as x approaches 0. The numerator now is 1 all over root 2 plus x plus root 2. Now, if you apply the limit point 0, we don't have indeterminacy 0 over 0. Up there, look at it. We have to bring in the difference of squares identity because at the point 0, if we put x to be 0, we're going to have root 2 minus root 2, which will be 0. And under here, we're going to have 0. So we'll have the indeterminate situation of 0 divided by 0, which cannot give us answer for that limit process. Okay, so here, at this point now, let us put the limit point 0 and see what we get. At 0, the numerator will remain 1, and the denominator will be root 2 plus root 2, which is simply 1 all over 2 root 2. So the limit as x approaches 0 of root 2 plus x minus root 2 all over x, that limit is actually 1 all over 2 root 2.